Hello, everybody who is watching. This is going to be the sixth lesson. This is the first lesson after we were supposed to come back, which will now be done online because of the coronavirus pandemic situation. Um, so we're gonna get right into it. So hopefully, if haven't touched math, which I wouldn't blame you for the past 2 weeks, you know, uh, March break's over technically twice now, so it's maybe time to get back into it. I have posted the first video is a review video, so if you've forgotten everything about algebra, I would highly recommend giving that a watch. But again, if you've significantly forgotten or don't understand things, I'd highly recommend going over some of the notes that we did before, just to refresh, what's going on in this, and then rewatch this video. Obviously, this is important not only because it's going to show up on your assignment assessments for this year, but then this unit, this note, and the next note are hugely important going forward. Again, when you get to grade 10, it is our hope, me and Mr. Tremoli's and all of the other teachers' hopes, obviously, that you don't lose out on any learning that would happen in grade 9, so that when you eventually get to grade 10, you'll be, just fine. Maybe even better off now that you have all this extra time to, sit at home and do math. There's literally nothing else to do, I'm guessing, other than, sit at home and do math. But in order to do that, we need to be following up on our lessons. For now, I think we'll be posting lessons regularly, including for this unit and the next unit. So stay tuned, and we'll jump right into it. I do a lot of preamble. So here we're going to talk about division of a polynomial by a monomial. So this stuff is fairly straightforward. Just like the rules for multiplication. The rules for multiplication was if you multiply like two polynomials, 2x cubed multiplied by 5x squared. You have to multiply the numbers, making that 10, and then you multiply the variables using exponent laws. So x to the power of 3 times x to the power of 2 is x to the power of 3 plus 2, because when you multiply, you add the exponents. So this was the answer. And the same thing applies really for division. When you divide things, you divide the numbers, so negative 30 divided by negative 6 gives us a positive 5. Then let's see, you have x to the power of 4 divided by x. Division rule exponents is 4 minus 1, which gives us x to the power of 3. Y to the power of 8 divided by y to the power of 2 is y to the power of 6. And z to the power of 2 divided by z to the power of 2 is z to the power of 0. We have to be careful here because we'll remember that if we get 0x squared or 0z, that would just be 0. And if you multiply anything by 0, everything becomes 0. But z to the power of 0 we know is 1. And so our final answer will be 5x cubed y to the power of 6, where this is just becoming 1. And this times, this is multiplied by 1, which just gives us 1. Which just gives us this, sorry, and that's our answer. So that's division. Again, hopefully we can see that it's not too complicated. So we're gonna move forward. Here we'll see that we have negative 4 divided by negative 2 gives us a 2 x squared. So we're gonna put the minus sign here, because this is a subtraction. You could actually consider this negative as part of the 6x, and you just make this a positive sign. That is also an option, but we're going to leave the minus sign as a minus sign and do 6 divided by negative 2, giving us negative 3x. And now what we're going to do is we're going to say negative is going to give us a positive. So that's plus 3x, but we haven't finished. We have a plus 2 divided by negative 2, which gives us negative 1, and plus negative 1 is the same as writing minus 1. So this is our final answer. if you wanted to write plus bracket -1, it wouldn't be wrong. But again, hopefully we're going to get accustomed to doing our assessments online now. So it's just going to be, a bigger version of the quizzes that the online part of the quizzes that we've been having. And so you have to know that these two things are the same thing. Hopefully that's okay for everybody. Again, here we have 3 different divisions that we're going to do first. All right, because the same thing we did here, we did each division individually. Individually, because they were all different terms, right? So we know that terms are separated by adding and subtracting signs. So we have one term here, which can be simplified, plus another term here, minus another term here. So these are all different terms and therefore are treated differently. So here we have 12 divided by 3 is 4, a to the power of 2, b to the power of 0, which is 1, so I'm just going to leave that, plus 3ab, 4 minus 3 is 1, 3 minus 2 is 1, minus 2, 3 minus 3 is 0, a to the power of 0 is 1, so I'm just going to not write that. 4 minus 2 is 2, so this is my final answer. Again, hopefully we're seeing what we're doing here. We're just dividing the numbers and we're dividing the variables. And we're dividing the variables using exponent laws. So I'm doing 5 minus 3 to give me 2. 2 minus 2 is technically b to the power of 0, but I don't have to write that because b to the power of 0 is 1. And 4a squared times 1 is just 4a squared. So hopefully we're all good with that. So this is a polynomial. So this is an extension. We're going to divide a polynomial by a monomial. So we'll see here that we have 2 different terms in the numerator and 1 term in the denominator. So just like multiplication, if we had -3 times -3x plus 9, we would use the distributive property. Right, we would put the -3 and multiply with the -3x and with the -9. The same way, this can essentially be written as -3x divided by 3 plus 9 divided by -3. Right, so I'm going to divide both or every term in the numerator by the denominator. Right? The denominator stays as a whole. You never split the denominator up. Very important. That's why we're only going to be dividing here in grade 9 by monomials. There will be no case where you're dividing by multiple terms. And in any case, that is not. There's not really a rule for that. It's impossible to divide by multiple terms unless you have some sort of factoring in place. Grade 10 stuff. We're not going to get into that. There's only going to be 1 term in the denominator, and we're going to multiply every term in the numerator by the denominator. Again, hopefully we're saying that when we divide, we're going to multiply every term in the numerator by the denominator. Of course, if there's multiple terms in the numerator. Up here, there was only like 1 term. All of this was 1 term. In this division, this was 1 term. 1 term. So here and here, so it wasn't really a problem until now. But here again, every term in the numerator by the denominator. So this division is what I'm going to do first. -3x divided by -3. -3 cancels out with the -3. I get x plus 9 divided by -3 is -3. This is just x minus 3. Every term in the numerator by the denominator. Again, I can split this up, or I can kind of use my there's not really a name for this rule. What does this look like? 3 different uppercuts? I don't know. I've been reading a lot of solo leveling recently. I'm all in. And okay, for those of you who don't know what solo leveling is, that's kind of confusing. But not the point. You all now know how I'm spending my quarantine time. Okay, so social distancing time. I'm not really under quarantine or anything. But okay, each term, sorry, we're getting off topic. Each term in the numerator by the denominator. So 5x divided by 5 is x. Minus 15y divided by 5, minus 3y. Plus 10 divided by 5, plus 2. This is my final answer. So again, a breakdown of how that happened was I took each term in the numerator and I divided it by the denominator. So 5x divided by 5. Again, I'm dividing the numbers, which gives me 1x. I would divide the variables. There's only one variable, so I just put the x. Minus 15 divided by 5 is minus 3y. Plus 10 divided by 5 is just a plus 2. So that was that question. All right, again, each term in the numerator by the denominator. We're going to write this out like so, just so that plus 10xy divided by 10xy. Again, each term in the numerator divided by the denominator. 20 divided by 10 is 2. X squared divided by x is x to the power of 1. Y to the power of 1 minus 1 is y to the power of 0, which is 1. So I'm just not going to write it because that's just 2x times 1. Again, we'll remember that the operation between all these things is multiplication, right? So I'm doing 2 times x to the power of 1 times y to the power of 0. So times y to the power of 0 can just be ignored there. Again, here I get a negative 3 because negative 30 divided by 10. X kind of goes away. And this, I believe, should be just an xy. That was my mistake from before. And now y squared divided by y is just 1y because I did 2 minus 1 gives me 1. Again, x and the x, I really did 1 minus 1, which gave me x to the power of 0, which is 1. So hopefully we're okay with that. And then 10xy, 10, I can cancel out the 10, 10. Technically, if you cross-cancel out the xy, that's technically fine because you're not really required to show this kind of calculation. So if you just got 1, that is technically okay for you to do. Now, because, we're not really sure as to how to check your work. Because if all the answers are multiple choice, well, that presents kind of difficulties. We might ask you to write out the answer and submit a picture. I think, I'm not sure. We're still a bit iffy on the details. We'll focus on the lessons for now and get to the complicated stuff later. All right, this is a fairly easy one. Every term in the numerator divided by the denominator. 24 and 8 cancels with a 3. Y divided by y. I have y divided by y, so 1 minus 1, 0. So I'm just left with the x. Again, the 0 means the 0 is in the exponent. I should stress that. I'm getting y to the power 0, not times 0. So y to the power 0 is 1, so I'm actually multiplying by 1, which is fine. I feel like I've repeated that a lot of times in this video, but it was good. It's important to not get confused there, and it's an area where I'm 100% sure people will be confused. Minus 16 divided by 8, cancel with a negative 2. Again, y divided by y is y to the power of 1 minus 1 is y to the power of 0. So I get negative 2 y to the power of 0. But I know anything to the power of 0 is just 1, which is negative 2. This is a full breakdown of how things are happening. You don't have to show any of this. You could just write minus 2. It's fine. All right. Again, each term in the numerator divided by the denominator. So again, we are going to put some invisible ones here just so I can divide the numbers properly. More so because there is a negative sign. So here I have negative 3 and negative 1, which gives me a positive 3. And here a squared a to the power of 2 minus 2, so a to the power of 0, which is equal to 1, which I'm not going to write. B to the power of 2 minus 1 gives me a b. Then here I have plus 5 divided by negative 1 minus 5. A to the power of 3 minus 2 is a to the power of 1. B to the power of 1 minus 1, which is b to the power of 0, which is equal to 1, so I'm not going to write that. Negative 4 divided by negative 1 gives me positive 4. A to the power of 2 minus 2, a to the power of 0, not going to write that. B to the power of 1 minus 1, b to the power of 0, not going to write that. This is my final answer. So hopefully everybody is good with what we have covered. Our new topic here was division of a polynomial by a monomial. So here we're going to do some practice work for the next lesson, but it's important that we do it because it's an important precursor. So we're going to find the greatest common factor of each of the following terms, 8 and 16. So if you are not comfortable with finding greatest common factor between numbers, I highly recommend you do some kind of practice work with this. Again, there are technically multiple ways to find a greatest common factor. So brief review, you can skip this part, those of you already know what a factor is. But again, what is a factor? A factor is a number that, again, first importantly, a factor is always equal to or smaller than the smallest number that you're finding. So again, if I had to find the greatest common factor between 8 or 16, my answer should not be bigger than 8. It is impossible for my answer to be bigger than 8, because a factor is by definition something that multiplies into one of these two numbers, right? So factors of 8 are like 1, 2, 4, and 8. So these numbers all multiply into 8. Like 1 times 8, 2 times 4, 4 times 2, 8 times 1. All these numbers multiply by a whole number to give me 8, and these are therefore the factors of 8. Factors of 16, 1, 2, 4, 8, 16. All these numbers multiply by a whole number to give me 16. These are the factors of 16. Now that I've listed my factors, the greatest common factor is well, as it says, it's the biggest one that is common between both these things. So here I see an 8 and an 8. That is my greatest common factor, right? So that's how to find factors between numbers. We are going to also look at factors between variables, and we'll take a look at this. Let's take a look at this in quite the same way as we did the numbers. We have x squared and an x. Now, okay, what are my factors of x? 1 is a factor of everything, so 1. And x is a variable. I don't really know what factors of x are, so it has to be x itself, right? So I have 1 times an x gives me an x. X times a 1 gives me an x. What about x squared? I have 1 can multiply into x squared. X can multiply by itself to give me x squared. And x squared can multiply to give me x squared. Now I hope you'll see that the factors of the variables are just individual components of the variables themselves. Because if you look at x squared, essentially x squared is nothing but x times x. Right? And here I have an x. So the greatest common factor is whatever is common between these multiples of products. That's what I'm going to take out. Because this goes again to the other way we do find the greatest common factor, which is prime factorization. Essentially, we're going to list the prime factors of each of these terms, and then we're just going to find we're just going to pick the common ones. And because we have variables, this is easy to do because we don't have to concern ourselves whether this is a prime number or not a prime number. You just see what is being multiplied into these things. So like we know that x is basically just an x. X squared is an x times an x. And then we see what's common. I have an x that's common and an x that's common. So this is my greatest common factor, an x. So hopefully that was okay. If not, I'll do it again. We're going to do that again right now. Just going to erase some of the stuff that's in the way. And my computer's being laggy. There we go. Okay, so 8x squared and 16x. So to find the greatest common factor of these things, first we find the greatest common factor of the numbers. Again, one way to do this is to list all the factors of the number out. So this always has to be smaller than the numbers, but which multiplies by some whole number to give me this required number 8 or this required number 16. Once you have listed all the factors, you pick the biggest one that's in both those lists, and we get 8. And again, x squared times x, we'll look at x squared as just x times x, and we're going to pick as many common things as possible. 8x is therefore the greatest common factor. Okay, let's try another one. 15 and 25. So 15 and 25. What basically multiplies to give me 15? A 1, a 3, a 5, and a 15. What basically multiplies to give me 25? 1, 5, 25. Right? What is the biggest number that's common between both of them? The 5. And so therefore, the greatest common factor has to include a 5. Now, let's look at the variables part. I have an a times a b times a c. In this part, I have a b times a c. I'm going to pick as much common as I can. So I have a b that is common here. I have a c that is common here. So I'm going to add those to my greatest common factor. So the greatest common factor here is 5bc. Let's look at this. 7 and 2. Again, factors of 7 are 1 and 7. Factors of 2 are 1 and 2. The highest common thing that I can take out is basically just a 1. So I'm just going to put a 1 there, even though I don't necessarily have to put that. Now, it would get tiresome to write this out. Hopefully we can see that x to the power of 4 is x times x times x times x. X to the power of 3 is x times x times x. I have 3 x's that are in common, so I can take an x to the power of 3 out. So hopefully we're seeing a pattern here. From the variable, if you have the same variable letter, that is if you have the same, like if you have x, x, x to the power of 4, x to the power of 3, the letter is the same, the lower power comes out in the greatest common factor. So that is a theme that we'll be seeing. If you have different letters, they apply obviously to different cases. So for example, here we see a y. We have y to the power of 3, y squared. My y squared is going to come out as my greatest common factor. That's the lowest power I have. I have a z squared and a z, which is z to the power of 1. So z to the power of 1 is the lower power. That comes out as my greatest. That comes out and I put it in my greatest common. That is part of my greatest common factor, I should say. Comes out as a terminology I will use in the next lesson, so we're going to talk about that then. But z to the power of 1, because that is the lower power, will be part of my greatest common factor. Okay, hopefully we are doing some homework here. I'm trying to make this, it's hard to make this as much of a class as possible, but those of you who do end up watching the video, I would like you to okay, this part's kind of interesting, so we'll actually do some of this over here. So we're actually going to do some of these questions because these are different kinds of questions. I would like you to find the answer to, let's just look at the hardest question, n, and write your answer in the comments section below this video. Put your name as well if your name is not apparent based on your username. again, there's like really no way I can stop like any kind of teamwork or collaboration from happening. So obviously teamwork and collaboration are completely allowed. If you want to do it individually, it's kind of quick. I'm just asking for one answer. Find the answer to n and type your answer out in the comments section below so that I know that you're keeping up with the videos and doing the homework. I know some of you are like already like bored of this video and be like, I know all this stuff. This is easy peasy, which is fine. If you get to the part of the video where you do have to do the homework, then do have to show me that you're doing the homework. Do that. Otherwise, I guess there's nothing I can really do about that. But it would be nice if you did it. Let's put it that way. So here we're talking about simplifying the expression. Now this is a curious example. Actually, it's not. Technically, I misunderstood this question. Again, here we are just going to divide each term in the numerator by the denominator. So 8t divided by 4 plus 12t divided by 4, which is 2t plus, whoops, there's no t here, plus 3 is my final answer. Okay, this is actually easy stuff. So after you do n, I'd also like you to do, again, I'll just pick like the hardest one here. Let's do, I guess, L. So I'd like to see the answers to N and L posted in the comment section below this video. So the homework I think is mostly very similar to what we've done, so I'll leave that for practice up to you. And just again, show me that you're doing the right work. Answers, comments below. Thank you. So that's it. There's one more lesson in this unit which we'll be going over. And until next time, peace.